Let's start out with the most obvious reason first. If you're at a big tech company, people actually care if your code is broken. If Google.com is down, that's really bad. It means that billions of people can't get answers to their most important questions. If your personal website is down, that's less bad. You only have one user, so the only consequence is that your mom knows you're a shitty engineer. Importantly, when you get results back from a unit test, it doesn't just tell you that your code is broken. It tells you why your code is broken. When you have thousands of developers and a code base of 1,000,000 lines of code, finding an error can be like looking for a needle in a haystack. At least here we know what part of the program is broken, and we can probably make a pretty good guess at what's wrong with it. Speaking of large code bases, as projects get bigger and bigger, they tend to add more features, and so it gets harder to manually test every bit of functionality. This is especially important for infrastructure teams, because it's hard to predict all of the insane ways that people will try to use your API. Today though, I want to focus in on one of the less obvious reasons for unit testing: collaboration. As students, we think all of the code we'll come across will be beautifully documented, but the reality couldn't be further from the truth. Often you'll hear people say that the code is the documentation. While occasionally this gets used as an excuse, there are some good reasons for it, and it's often done as a way of life. The problem is, if you document your code using text or comments, a lot of times people will change the code, but forget to change the underlying documentation. When you write a unit test, it not only documents the expected behavior, but it also verifies that the behavior is still what you said it was. What's more, tests can serve as a pretty effective way for understanding a particular bit of software. A test not only describes a function, but shows you how to call it, and the structure of a test case can often be much easier to understand than the underlying algorithm. As a reviewer, this makes your life easier because the person submitting the pull request has already documented what they've done to test it. If I see a unit test, I know that the code already works for this particular use case, so I don't have to mentally verify things that would cause that use case to fail. I can focus more of my attention elsewhere, like digging through interesting edge cases. Actually, if you don't write unit tests, that also makes my life easier, because I can write one comment on your CL and then go about the rest of my day. Where things get really interesting is when you start working in a shared environment. If you have a bunch of different engineers all trying to make changes to the same location, you're going to need to put in some extra work to make sure all of those changes are in sync. For example, if you rely on some API to get the weather, and that API changes under the hood in the time it took you to write that change, then your entire program might return nonsense. Inevitably, somebody will force submit a CL that breaks the entire codebase, and it's really helpful to be able to point to the CL that caused the outage so you can tell them to fix their change. Even if you don't have a CI/CD pipeline, or if you write a new unit test, you can always bisect the linearized commit history to find the offending CL. This gets to a core reason of why unit testing is so important. It prevents other people from making changes that break your application. Now, if some team that you rely on decides to change the behavior of their public API or break something under the hood, they have to send you a CL explaining what they're doing and why it breaks your unit tests. Instead of dealing with ground shifting under your feet, you can confidently jump in your Jeep and shout at the maintainers, "This is America." But what if you don't fall into any one of these categories? What if you work on small teams, building non-critical software, you have a small code base, and your changes really are easy to manually test? Sometimes it's okay to program like a cowboy. Life is short, and if you spend too much time writing test cases for your personal projects, there's a good chance that you won't spend enough time writing features, and that nobody will ever use your software anyway. If you want to be part of our next series, Guess the ELO, leave a link to a public GitHub repository that you've written, and I'll do a code review of some of our viewers' existing code here on this channel. Thanks so much again, and I'll see you in the next one.